Welcome to solverfy.
Okay, so for this exercise, we need to consider, well, the variables that are involved in the Java language. So the point is that the Java language accepts variables that have length between 1 and 65,535. Okay, so really big uh, strings of characters. And these variables can have uppercase letters, lowercase letters, the dollar symbol, the underscore symbol, and the digits. So we need to count how many possibilities for variables we have in Java. So the point here is that first we have all these possible symbols for the characters of these strings. So need to count all the possible outcomes, right? So all the possible characters that we can put on a string for the name of the variables. So uppercase letters we have 26 possible letters. Lowercase again 26. We have one symbol of dollar, one underscore symbol, and we have 10 digits. So in total, if we sum all them, all these possible all these possibilities, we have 64 characters for a Java string. Okay, so let's focus on this part. So we have 64 characters for our string, and the name of the variables have length k, and k is restricted from 1 to 65,535. If we want to count all the possibilities, we need to count all the possibilities of different lengths of strings for the name of the variables. That means that we need to involve a sum from k equals to 1 to 65,535. Okay, and this is only because this sum is inclusive. In case that is not inclusive, we need to start from 2 and from up to 34. But in this case, the restriction the interval is inclusive, so we need to consider the borders of the interval. But what we need to sum? Well, let's suppose that k is equals to 2. That means a string of a two length string. In each position of this string, we have 64 possible characters that we can put there, between the uppercase letters, the lowercase letters, the dollar symbol, the underscore, and the digits. Okay? But we need to consider one more thing, and is that at the beginning, okay, and that's important, the first position cannot have any digits. So in the first position, no digit is allowed. No digits. So the first position is going to be, we're going to have 54 possibilities, okay, between uppercase letters, lowercase letters, and the two symbols that we have, that the dollar and the underscore. And for the rest, well, we have the 64 possible characters to put on the string. Okay, so this is more or less the structure of the strings. Let's see what happened when k is equals to 3. The length of the string is 3. So in that case, we have here 3 positions. In the first position, we have 54 possible characters, and for the rest, we have 64 and 64. So you can see that we have a pattern that depends, of course, on the value of the length of the string. First, we have here the 54 for all these strings, because all of them need to start with a character different from a digit. But for the rest, we have 64 possible characters, and those are raised to the power of k minus 1. Okay, to the power of k minus 1. And you can verify here, 3 minus 1 is 64 to the square, that count the two remaining places of the string, and we can put any character of the one that I listed before. So to count all the possible strings, we need to solve this sum here from k equals to 1 up to 65,535. There is a way to solve this because this is a geometric series. So this is going to be equal to 54 times 64 to the power of 65,536 minus 1 over 63. So this is the real solution of this exercise. But in case that you want an approximation, because this is the real value, this is analytic solution, the approximation for this summation is around 5.5 10 to the power of 118,364. So you can see that is a monstrous number.